Hey, what's going on today? Just going to talk a little bit about weather and climate today. This is my son, Riley. Say hi.
Hi.
Hi. All right. Do you know about weather and climate?
No.
Okay. There's a difference between weather and climate. Okay. Weather's like the day-to-day information you get. So weather's like, what's it like out right now? Look outside.
Day.
Is it raining or is it sunny?
Sunny.
You know what the temperature is about?
What?
It's about 38, 40 degrees, but it's going to get up to 54 today. That's the weather. Okay. Climate's a little bit different. Climate is like your yearly averages. So we live in a temperate climate because we have 4 seasons. What are the 4 seasons?
Summer, spring, fall, and winter.
Very good. Summer, spring, fall, winter. So that's kind of like our climate. Like our summers get fairly warm, right? Our winters are fairly cold. We sometimes get snow, even though we didn't get snow this year. But that's climate. Where if you lived in let's say the Caribbean, right? That's a very different climate. So therefore, your daily temperatures would be somewhat uniform year round because you live close to the equator. All right. So weather's the day to day. Climate's like the yearly averages. Okay. So what dictates our weather? What dictates our climate? Where does all of our energy come from?
The sun.
Look, you know that, the sun. So really what affects our climate is the sun. So it traps solar energy, which you can see right here. Latitude. Do you know what latitude is?
No.
So latitude are kind of these imaginary lines that measure how far north or how far south you are from the equator. Do you know what the equator is?
Like it splits the earth in half.
Yeah, it's like the middle of the earth. So the further you go north, right, you go further up in north latitude. The further you go south, right, you get further south in south latitude. What do you think happens to the temperature as you get away from the equator of the earth? You go further north, what happens to the average temperature? So you get warmer or colder?
Colder?
Yeah, it gets colder. It's warmer at the equator. And it's warmer at the equator because that's where the sun's the strongest, which we'll talk about in a second. All right. So because of these changes in temperatures, you get transporting of heat. Oh, let me go back. You get transporting of heat by winds and ocean currents. All right. So when you kind of think about this, we know the equator is where it's the warmest, right? The North Pole, South Pole is where it's the coldest. Well, when you get differences in temperature, you get movement of air and movement of water. So the concept I like to talk about this is, have you ever made macaroni and cheese or pasta before? Have you ever made it yourself? No. Okay. So, but if you've made it before, right, you know, like when you see me make it, right, you have to boil the water first, then you put the macaroni in, and then as soon as you put it in, I usually stir it right away, right?
And you put the cheese in.
Yeah, well, before we do the cheese, we're talking about boiling the pasta part, right? So then we put it in, and once I stir it once, you're kind of good. It kind of takes care of itself, and because you get the water boiling again, and you get currents inside the water, right? The water is really, really hot at the bottom of the pan next to the heat source, but where it's coming in contact with the air, it's a much cooler. So you get these currents inside the water, and that's all the bubbles kind of moving around. That's kind of moving your pasta around. So once you stir it once, the currents kind of take care of it. We have those same type of currents going on at a global level, right? With both ocean currents, but also wind currents. And that's what really brings our weather. Okay. So the question is, why is it so much warmer at the equator than it is at the North or the South Pole?
Because the sun is mostly facing the equator because it's always in the middle.
Yeah, so the sun faces the middle, and that definitely plays a role, but it has to deal with a little bit of physics. Do you take physics?
No.
No. Okay. So it has to deal with angles. If you've ever taken physics before, which you guys have, right? F equals ma, right? Force equals mass times acceleration. But the real secondary part of that, it's times the sine of the angle. If I push directly on something, I'm going to apply all the force I possibly can. If I push at an angle, right, I'm not going to be pushing it as hard because I'm not going to be putting direct force into it. So Riley's really here for this demonstration because I've been wanting to do this for a long time. Okay, stand up. And you need to stand right here, right in front of me, right here. But face me. Okay, like that. Okay, so here's an idea of force and angle. So at the equator, the sun is directly hitting the equator, right? So it's hitting at an angle. It's almost like a 90-degree angle. So that's like if I were to punch my son as hard as I can, don't move, right? Hard as I can in a straight line. He's going to get hurt really, really bad because all of that energy is going to be directed into his chest. Right, come back here. However, at the poles, because the Earth is curved, right, the sun's hitting at a different angle. So it's like if I took a wild swing and I just grazed his chest a little bit. It might hurt a little bit, but it wouldn't hurt as much because I'm not hitting him at a direct angle. I'm hitting kind of grazing angle. So that concept, thank you. You can come sit down. So that concept is the reason why the sun is more intense at the equator than it is at the North Pole or the South Pole. The other thing that's kind of interesting about the poles and about seasons is right now we're in spring, but we're going into the summer. And so the northern hemisphere is going into the summer, which means the southern hemisphere is going into winter, right? And that's not because of being closer or further away. It deals with the tilt of the Earth. The Earth isn't directly perpendicular to the sun. It's actually at about a 23-degree tilt from the sun. So as it's rotating around the sun, when the top of the Earth is tilted towards the sun, so let's say this is the sun and I'm tilted towards the sun, that is when the northern hemisphere is in summertime and the southern hemisphere is in the wintertime. But when you get to the other side and it's tilted away, I put my hands up, now the northern hemisphere is tilted away, the southern hemisphere is tilted towards the sun. So that's how you get kind of the difference between the winter and summer in the northern and southern hemisphere. And then if you live in the equator, do you have winter or summer? I mean, sorry, there's no winter. It's like summer all year long, which is kind of cool. All right. So that's the lesson for today. The next lesson is going to be habitat niches, which we'll talk about next. Thanks for participating. Awesome. All right. Thank you very much. Talk to you guys later. Bye. Say bye.
Bye.